You start?
Yeah.
The dissection will start with the external and the interior of the eye of the car eye, and we will be identifying the ocular humor, clear fluid area between the lens and the cornea, composed mostly of water, help maintain the shape of the eyeball. The blind side of the eye that will be identified is in both of the chakra area of the retina where the receptor cells cover to form the optic nerves. Then we'll go back in the same channel. We'll begin to identify in the correa, the thin dark sheet of tissue between the retina and the sclera, and we'll come down in the same cycle of this muscle, and you'll find the coherent transparent coverage that allow light to enter the eye on the preserved specimen, which is we are just demonstrated. The corner is the cloudy area. The iris is a diaphragm that regulates the size of the pupil. The lens is a back cover of the transparent structure of the focus. The light coming in through the cornea, in which of course is in the same jump chamber as we displayed it before coming out to this. And you identify the lens, as we just said. The optic nerve is at the back portion of the muscle that discovered most of the activities that connected to the brain, which is the bundle of the nerve cells that send signal from the eye to the brain. And the people are right laying over this of the eye, where you will find out that the the people is an opening through which the light enter the eye through this chamber. This both chamber is a dedicated information receiving for the sclera is an outer covering right here. It's an outer covering of the eyeball, a tough opaque sheet of the connective tissue that cover the tissue that protects inner structure of the eyeball and helps maintain the rigidity. The tapetones lucidity iris itself is in the chamber of the correa that connected to the corneal tissue. Both are all intertwined, operating together as that make it help in the light visions in reflecting available light back onto the retina. Both are dedicated, more especially you can see it in animals. More animals at night, and you can see that. So when you come up to the iris of this, where you see the dedicated muscle sitting down, is the ventral hormone, which require the vacuum fluid that fill the ventral body, help maintain the shape of the eyeball. In this cycle, you will find a lot of protein in here. As you're looking at it here, you will see a lot of protein that is so dedicated, and this protein is so important that you will begin to identify a lot of protein here, and it's dedicated. And at night, you will begin to understand that when you flash light in the eyes of a raccoon, dog, cat, and nothing, you will see the reflection. And this makes it so dedicated. The green spot that you see here is in the tumor that were collaborated as where we talk about the ocular hormones that make the fluid filled in the area between the lens and the cornea, composed mostly of water, help maintain the shape of the eyeball. So the blind spot is right here. As we're looking in here, you can easily see it right now that you're looking in here, and but which of course it just will collaborate with the receptor coverage of the optic nerves. Then from there we have the the dedicated information right now that we're supposed to say is in every eye cycle is so dedicated that in the human you can't find most of it, but on the car eye we identify these dedicated information that we have to understand that in a layer of this, every layer is functional and it will collaborate closely with the brain. More especially the retina, as you see it laying up on the body of the raw receptor cells of the retina that are responsible for perceiving difference in light intensity. When people flash light in your eye, and other people can go blind, other people it can give them eye disease conditions and get them problem. So that's in the eye dissection.